Good morning, Blue Group. This is our next section of our notes. I know you've been waiting for our next section, so here they are. This is chapter 1. We're only in section 2, but this section in this chapter takes a long time, so we're going to spend quite a bit of time on each section. So our first thing is to look at our I can statement. Our I can statement for today is that I can solve multi-step equations. So we're going to use different steps, combining all of our different steps together to be able to solve an equation. These notes look a little overwhelming, and I promise we'll go through them step by step, but make sure you're paying very, very close attention so we can work through these, okay? It does take some effort and some time to look at these. First, you'll see that we have all the properties from section 1 up here. The addition property means if we add the same thing to both sides, the equation is equal. Subtraction property, same thing. If I subtract the same thing from both sides, my equation remains equal. If I multiply the same thing to both sides, my equation is equal. And if I divide both sides by the same thing, they are equal, okay? Make sure you remember these properties. Example 1, we're going to look at our step-by-steps while going through this. So always, if you ever get stuck, please look at our examples and our step-by-step, okay? First thing is that we need to write the equation. Well, our equation's already written, so we're good. Now we need to combine like terms. So I'm going to go ahead and shape the different things that I know are like terms. Remember, like terms are either the same variable or they're just a number, okay? So I know that 3x and 4x are like terms. They both have the same variable. Well, 3x plus 4x is equal to 7x. Then I'm going to just bring down the rest of my problem. Minus 3 is equal to 46, okay? And I'm going to draw my line down here so that I know what each side is. Second thing, it says use your properties to add or subtract the constant from both sides. A constant, remember, is the number without the variable. So what number do we have here that's without the variable? You should be thinking that number 3 does not have a variable, and you're right. Now you need to use the inverse operation or the opposite operation. Here, we're subtracting, so we need to go ahead and use our adding property to add 3 to both sides. Okay, well, negative 3 or minusing 3 plus a 3, that's going to cross off. It's gone. So what's left on this side? 7x. Now I have 46 plus 3, and so I can add that, and I know that's going to get me to 49. Now we're back at a one-step equation. This is what you did yesterday and all last week, so you should remember how to do one-step equations. Well, there's no operation shown here, so I know it's going to multiply. If I look back over at my steps, it says use your properties to multiply or divide from both sides in order to isolate your variable. So I want to get my variable by myself. Now, if I want the variable by itself, I need to do the opposite or inverse operation. If I'm multiplying here, the inverse operation of multiplying is dividing. So I'm going to divide both sides by 7. I know that 7 divided, multiplying by 7 and dividing by 7 is going to cross that off. So I'm left with x would be equal to, it's 49 divided by 7. You may use your calculator. We know that equals 7. Okay, you solved it. You got the variable by itself. Now the last thing is very, very important. It says check your answer by plugging your variable or plugging your answer back in for the variable. So we're not done yet. So I'm going to do 3 times 7 plus 4 times 7 minus 3, and that should give me 46. Okay, so what I've done here is I put 7 in for x. 3 times 7, 4 times 7. Go ahead and plug it in your calculator. Test it out. I can do it by hand, but I would like you to put it in your calculator. Does that equal 46? And you should give me a check mark that yes, it does. Use your calculator, plug it in, make sure it's there. If you don't have a calculator in front of you, make sure you go grab one. You can pause the video if you need, but make sure you're using it to find and check your answer. When you check your answer, you know that you got it right. So it's very important you do that. All right, now on to example number 2. Example number 2 is a story problem. I know how much you hate story problems, but remember you have to know how to do it. And you see it everywhere, so you have to make sure you're still practicing them. So example 2 says, I went and bought a tree that was 6 feet tall. Every year, it is supposed to grow 1.5 feet. So I started with a 6-foot tall tree. Every year, it's going to keep going up. How long will it take for the tree to be 30 feet tall? Okay, so I have a tree that's already 6 feet. Every year it's going to keep growing and growing and growing and growing and growing, 1.5 feet, and I want to know when it will be 30 feet tall. Okay, so here's my picture to show me what I'm trying to find. And this would be 1.5 feet, 1.5, 1.5. And how many times is that going to go all the way up till it gets to 30? So when I'm trying to fill in and when I'm trying to set up an equation, I like to set it up like this. Okay, where this tends to be always the total. We always have a constant number here, so a number that's by itself. Then this tends to be a number with a variable. Okay, that tends to always be what happens and how it's set up. So I'm going to go ahead and show you how I would set this up then. Do we know the total? We do. It says that we want it to be 30 feet tall by the end. Okay, so we're trying to get it to 30. So that's kind of our total. We know that. What is our constant? Our constant is what it already comes as. It's not going to change. Your constant number is the number that will never ever change in a problem. There's nothing that's going to change it. So how far did our tree, or how tall was our tree right from the beginning? 6 feet. So we know that that's 6 feet. Now, in this section, we're also going to have a circle, which means that's going to be our operation. We need to know what operation we're going to use. So it says every year it is supposed to grow 1.5 feet. So our number that's left, our number is 1.5. And our variable, we can make up our variable, but I'm going to use y because that's for years. Now, what operation? We're going to multiply or divide. If we're trying to see for 1 year is 1.5, then another year we're going to add another 1.5, and another year is going to be another 1.5, and another and another. We're continuing to add them up, which means there's multiple different versions, which of course you know means that I'm going to multiply those. Okay? Now, I need to know if this is going to be adding or subtracting. I need to fill in this bubble here. Are we adding 6 feet or are we subtracting 6 feet? If we know it's already started at 6 feet, we already have 6 feet to our total. So this is going to be adding. Now I'm going to rewrite it so I can go ahead and solve this. 1.5 years plus 6 is equal to 30. Now I can solve it like I did with the one above. So I'm going to go ahead and draw my line down. And my first step, combine like terms. I don't need to combine any like terms. All my two terms are alike already. Then I'm going to go ahead and go to my next step. Use your properties to add or subtract the constant from both sides. Well, I'm adding in the problem, so what's my opposite operation or my inverse operation? My opposite operation is subtracting. So I'm going to go ahead and subtract 6 from both sides. Positive 6 minus 6, well, we know that those are going to cross off. On this side, I'm going to bring this back down. 1.5y is equal to 30 minus 6, which is 24. Okay, now this is multiplying. So the opposite of multiplying is dividing. So I'm going to divide by 1.5. We'll go ahead and divide. 1.5 divided by 1.5 is nothing. So I'm left with y. Once you plug 24 divided by 1.5 into your calculator, you're going to get 16. Okay? This means it's going to take 16 years for the tree to reach 30 feet. And that does make sense. Now, remember I said we always have to check our work. So 1.5 times 16 plus 6 should equal 30. When you plug that into your calculator, you will see that it does check. We are all done. Okay, this is a really, really tough lesson. So if you didn't understand it, I completely understand, and I would like you to go back, watch it again, watch me go through the steps, read your steps again that I have provided you here, and double check your work. If that still doesn't make sense, then I'm going to come around and make sure I can talk you through it so you can understand it. And I will be by for this lesson, of course, because this lesson is very tough and challenging, and there's a lot of steps involved. There are a few homework assignments, a few problems. I think there's only about 3 that you need to do. So please try your very, very hardest to try one on your own. See what you remember, follow the steps, follow what I said, and see what you can do. I will be by to check you. Thank you very much. Good job.